Thank you all for joining us this afternoon for another Talks at Google event. We have today Dr. Don Johanson. He is the discoverer of Lucy. Ever since finding that skeleton, that hominid, his team has discovered over 350 skeletons of that same species. So it's really an amazing story. For over 40 years, he's led this program, and currently is working on the Institute for Human Origins, if I'm not mistaken, of Human Origins. Institute of Human Origins. And so he'll talk to us about that as well. He is also speaking on behalf of his book, Lucy's Legacy. So with that, please join me in welcoming Dr. Johanson to Google. Thank you.
Thanks very much. It was so convenient to have somebody pick me up at my house in San Francisco and drive me down here. I actually finished my talk in the back seat of the car. But I'm happy to have an opportunity to speak at Google, an organization that absolutely everybody knows about, and if they don't, they can Google it. So I have had a wonderful privilege of fulfilling a childhood dream. And I'm a professor at Arizona State University, although I'm living here and teaching only online, which I'll mention in a bit. But I try to tease out those students who really have a passion for something, and I think probably that's the most difficult thing in education in this country right now, is that so many students don't have a passion or a commitment to something at a young age, and they flounder or they say things. They'll come to my office and they'll say, "But geez, there's nothing left to do in the world." And I was fortunate in having a childhood dream. I read a book when I was 13 years old called Man's Place in Nature by Thomas Henry Huxley, who was one of Charles Darwin's closest buddies. He was often called, as you may remember, Darwin's bulldog, because he was really the proselytizer in many ways for Darwin's paradigmatic shift. And to use that word carefully, that was a really paradigm shift. Can we turn the lights down a little bit? That'd be great. And he gave public lectures throughout Great Britain on evolution and Darwin's origin of species. And he thought it was terribly important to understand our place in nature and called his book Man's Place in Nature. And one of the conclusions that both he and Darwin came to was that the idea of natural selection and descent with modification and so on is not restricted just to non-human creatures, that it was also applicable to the human species. And they concluded that based on the similarities of apes and humans, particularly African apes like chimps and especially chimps and gorillas, that we shared a common ancestor. That's one of the tenets of evolutionary thought, that there is descent from a common ancestor. And they predicted at a time when anthropologists, biologists, geologists were extraordinarily Eurocentric in terms of understanding human origins and pinpointing Europe as the finishing school for humanity. And it wasn't until the mid-1920s that fossils that were discernibly on the human family tree of great antiquity began to be discovered. And reading that book as a young teenager, I was absolutely riveted by the idea that we shared a common ancestor with the extant apes, and that there was, at least at that time, the beginnings of discoveries like Neanderthals from Germany and France, and also Cro-Magnon, as we call them, Homo sapiens from southern France. And I wanted, as a young student, to be part of that search. And I fortunately was accepted to an undergraduate school, the University of Illinois, where I studied anthropology, and then went on to the University of Chicago, where I did my PhD with a professor who I sought out, who had an expedition in Ethiopia, in Africa, and I sort of talked my way onto that dig and spent my first year in Africa in the summer of 1970. So that's 45 years ago. And when I first entered the field of what's called paleoanthropology, the study of human origins, not the study of old anthropologists, but when I first entered the field of paleoanthropology, we had about 6 different species on the human family tree. Today we have upwards of 23, 24 different species, so that the tree of human evolution has become exceedingly complex. Today I've chosen to give some of the biological background to being human. One of the questions that we all ask ourselves, whether you're philosophers, anthropologists, whether you're in the tech business or whatever, is what is it that makes us human? And this is, of course, the quintessential question of anthropology, which is the study of humankind. And it's always been studied from a cultural point of view. People will say, well, you know, what makes us human is we sing, we paint, we dance. Every society has some creation myth of some sort, and so on. These are, I think, really the results of three core areas that we're beginning to study. Oh, and by the way, if anybody is thinking of tweeting anything, I'll give you these addresses. And central to understanding what makes us human is really this sort of interactive evolutionary dynamic between cultural evolution on the one hand and biological evolution on the other hand. I say that it's very important to reinsert the idea of biological evolution, because anthropologists not far from here, in a little school over in Stanford, at Stanford, had a schism in its anthropology department a number of years ago, because many of the social cultural anthropologists thought that once culture comes in the door, biology jumps out the window, and that we are no longer part of the natural world. We are, as one anthropologist, Alfred Kroeber, wrote, super organic beyond culture. And I think we have to really understand the biological roots of who we are and how that in many ways set us up to be the most dominant, the most intelligent, the most creative, and at the same time, unfortunately, the most destructive species we know of in our solar system and perhaps anywhere in the universe, which is a rather provocative issue. But certainly on this planet, we are in control. And how did that happen? And I'm going to just touch on this at the beginning, because the Institute of Human Origins, which is located at Arizona State University, grew out of an idea I had in 1981 when I moved to Berkeley and founded this research institute. I wanted a place that was dedicated to the pursuit of finding the cultural remains and the fossil remains of our ancestors and try to fit them. Can these lights come down anymore?
Unfortunately not for the video. I'm sorry.
Oh.
Sorry about that.
Okay. I wanted a place where we sort of had a group of paleoanthropologists, geologists, archaeologists, people who were dating rocks and so on, came together under the rubric of a single research institute to pursue the past. And in 1997, that organization was acquired by Arizona State University, providing us with greatly expanded opportunities, and also the opportunity to leave descendants, which is, after all, the goal of all evolution. We were now leaving students, and before we were not. And moving there, we recently began to move out into other areas and try to understand the evolutionary foundations of human uniqueness. Because if you read people like Steven Pinker in The Language Instinct and others who are evolutionary biologists, much of what we're looking at must have some explanation that can be rooted deeply in the whole idea of natural selection, and that that we are who we are because of that intangible force that we call natural selection. So the rubric that we're working on, we have about 14 different teams working in different places, everybody from psychologists to field archaeologists and so on, is to understand the evolutionary interplay of these three major insights, I think, into what makes us human. We lead lives of extraordinary cognitive complexity. No other animal comes close to the cognitive complexity that we have. And we have an extraordinarily expensive organ, which is called the brain, which demands a lot of energy, a different way of eating and different foodstuffs and so on, and the abilities to gain those. And we communicate through symbolic language. No other animals do that. No chimpanzees, as close as we can get to ourselves, who do sign and so on, talk about tomorrow or yesterday or what's going on in the next room. So we are remarkably unique in that regard. Second, we have a capacity for culture that is unsurpassed. And particularly, our culture is cumulative. And people here at Google, people in this part of the world, in Silicon Valley, so to speak, understand what that means. Biological evolution is glacially slow. Okay, over a very long period, very minor changes occur. But in terms of our culture, whether it's technology or what, our advances are cumulative. So once culture begins to be our sort of savior, in the sense that everything we do is filtered through culture, you have a growth like that, which is extraordinary and unique and different from any other creature that we know of. And thirdly, although it may not seem like this when you open up your morning news, humans are the most cooperative of any vertebrate on the planet. No other creatures, no other species come anywhere close to cooperating. If we were a chimpanzee troop, for example, male-dominated, of course, and a male chimp from another troop came in, we would kill him and eat him. We cooperate more extensively with each other than anyone else, any other species on the planet. And at the moment, this is a work in progress. And maybe if I'm invited back, once we have spent a few years looking at this, we may reveal some very interesting, deeper understanding of what it is that makes us human. And interestingly, this is a proposal that is supported by the Templeton Foundation, which is a very religious foundation, as you may know. Templeton supported research in various fields, but you had to tie it and try to make science and religion kind of fit comfortably in the same textbook. And there are no such restraints based on us. Well, as I said, there were very few species of fossils when I first started working in 1970, species of humans. But today we have a fossil record that takes us back to about 6 million years. We came from something like you see on the left here, much more ape-like, with a projecting face, a brain about the size of a couple of cups of coffee that we have in the morning, about 380, 400 cubic centimeters, walking upright. And these creatures we collectively call Australopithecus, or ape man, as they are sometimes called. And they take us back to about 6 million years ago. And the one feature we see that continues back that far is upright bipedalism, what I'm doing right now, and freeing our hands from locomotion and beginning to use them for other ways of manipulating the world around us. It's interesting looking at this because as we grasp a branch on one of these, the human family tree, the roots all lead back to Africa. It's where we had a common ancestor with the African apes. It's where we first stood up about 6 million years ago. It's where we first began in the middle to expand brains. Lucy's brain was about, as I said, about 400 cubic centimeters. Our brains are about 1,400 cubic centimeters. It's where our ancestors began to fashion stone tools in a very regular way at about 2.8, maybe 3, maybe 3.4 million years ago. It's a big debate right now about that. Where our bodies were transformed from ape-like bodies that had very short lower limbs to having very long lower limbs, which is our lever arm for getting around, right on up to the emergence of Homo sapiens at 200,000 years. So all these features that we think of biologically and culturally in terms of the birth of culture with stone tools, and probably culture before that with things that don't preserve in the fossil record, all premiered in Africa. So I like to look at no specific place in Africa as the cradle of humankind, rather Africa as a crucible where all of this experimentation was going on. I told you that I read Huxley. I didn't read Darwin until a little bit later. He only had one not very interesting black and white diagram in his book. Huxley had pictures of apes and Neanderthals and stuff. And Darwin shied away, as you know, from talking about human origins. He was particularly worried about upsetting Emma, his wife, who was a very devout religious person. And you have to read The Origin of Species to the last page, the second to the last paragraph, before he says, light will be thrown on the origin of man in his history. And that's all he said. That was enough. But it's true that he tried to stay away from this because he didn't want to upset Victorian England. He didn't want to be the center of great controversy. And yet later on, after chewing on this idea for so long, in 1871, he wrote a book called The Descent of Man and wrote up a number of scenarios of how we became human. He and Huxley would go to the zoo and they'd see chimpanzees and they'd see how similar they are. I'm sure everyone in this room has seen a Jane Goodall documentary or gone to a zoo and looked into the eyes of a creature that is remarkably reminiscent of maybe somebody you know. And there's no doubt that they're not only very similar in their appearance, but details of their anatomy, as Darwin and Huxley examined their teeth and jaws, are very similar to ours. And from the work of people like Goodall and many others, there are certain behaviors that are reminiscent of who we are. They certainly experience a wide range of emotions that we would have traditionally thought of as only being human. And with the Human Genome Project and the Chimp Genome Project, chimps aren't running that project, but the Chimp Genome Project, we're about 99% identical in terms of our DNA, which is one of those homologous features that really shows us that there was a common ancestry there, and it was not too far distant in the past. So there's no longer any question among most people that these two creatures shared some sort of a common ancestor somewhere about 8 million years ago on the continent of Africa. One of the features in Africa that has been so beneficial to us is one of the great geological structures on the planet, which is the Great Rift Valley. It runs all the way from Mozambique in the south, divides here, and continues up through Tanzania and Kenya, and up into the Horn of Africa, which is this area just up in here, the little triangular area known as the Afar Triangle. And that was an area that was really terra incognita until the late 1960s. I made my first visit there with a French geologist who had been exploring that area. He had found bones of big animals. He didn't know what they were. They were elephants and pigs and rhinos and monkeys and antelopes and so on. And during the course of his work, I met him in Paris at a cocktail party, and he said, "You should come with me." And I did, and this is the place where I have worked since 1972. You see the Rift Valley, you see Addis Ababa, the capital of Ethiopia. The Rift Valley, this is Lake Turkana, which used to be Lake Rudolph, continues up here into that very large triangular area, which is much of it below sea level. It is where the Horn of Africa, due to continental drift, is beginning to move away, and it is rifting the surface of the face of Africa. And it's and very ancient geological layers are being resurrected because they're being now eroded and exposed. And this is a classic picture. This is the first view I had of the site of Hadar, as it's called. It's the local name, an Afar name, the Afar people who live there. And as far as you can see in the distance, you see these beautiful badlands. And there are a number of features in there in the distance which are very light colored, and those happen to be volcanic ashes. And those volcanic ashes lend themselves to argon dating. So we can tell in a precise way how old these geological strata are by doing potassium argon or argon analysis. And they're very horizontal, as you can see. They've not been disturbed very much by tectonics. And in addition to that, you can't see it quite as well here, but they're fairly fine-grained, which meant that the deposition was a very slow, quiet deposition. It wasn't a raging river that breaks up bones and distributes them. It records and preserves and fossilizes things in place. And here is an aerial view. I did a little work for, I think this was a NOVA program a couple of years ago, and took some photos. We were very fortunate. There was a river running right through here, so we had a permanent source of water. We're out there for 3 months a year, 2.5, 3 months a year. And I don't know how many of you have spotted my camp, but that's where we camp for 2.5 to 3 months in the middle of nowhere, which means we have to bring everything with us. There's no Walgreens down the street or Safeway. So it is a very remote place. It is dangerous in many, many ways, lots of snakes. But also there are two rival tribes that live on either side of that river. And we've worked north of the river, which is towards the top of the screen, since 1972. We wanted to work south of the river, but we're unable to because of the nature of the people there who like to shoot you. So we've continued to work there over the years. And here's a closer view of camp, what it looks like. various tents set up for personal tents. There is this is a work tent over here. There's a kitchen tent. There's an eating tent. And a team of scholars and students will go out there for 2.5 to 3 months to regularly search for, excavate, and hopefully discover remains of our ancestry. It is, as I said, a fairly hostile region. The Afar people, the first year I worked there, our camp was burglarized in the middle of the night by these people. They didn't know who we were. Fortunately, we didn't get shot. But over the years, we've made great friends with them, and they are regular participants in the explorations in these expeditions. So we worked there between the early 70s and 1980, when Mengistu took over Ethiopia and Haile Selassie was deposed. And this is a typical group of paleoanthropologists and geologists, archaeologists, fossil pollen specialists, pig specialists, elephant specialists, kitchen crew, and so forth and so on. And, I may be here talking about these in these spotlights, but if it wasn't for this integrated effort, this multidisciplinary approach, I wouldn't be able to tell you the details that I'm going to tell you. Work continues now at night. The romanticism of the kerosene lamps is long gone. We have solar panels, so we have electricity, and we can charge up our computers, and we can communicate with the rest of the world. And sometimes people work in the evening, as you saw. And there's really no way to find these fossils except to go out and walk and look and walk and look, and to hope that your eyes will fall on something exciting. These fossils, this is an elephant foot that is eroding out of, on top of it was a beach sand. Below it is a deeper water deposition, interestingly, so it meant that the lake was probably receding at this point. And you see a small group of people in the background for scale, and you might spend 3 or 4 or 5 days in there with a team of 5 or 6 people. But this elephant, 3.4 million years old, was found in place and still, incredibly, to believe, it's still articulated. So regularly, research or survey teams like this will go out and with a trained eye, try to find these fossils that have eroded out from their ancient beds where they've sort of lain in suspended animation for millions of years, and give us a better insight into our early human ancestors. Sometimes it's a discovery of a single tooth like this that led to an entire face of one of these early Australopithecus creatures. You see in the background a team of people who are beginning to set up a screening operation and have cleaned this slope totally of the loose sediment on top and recovered most of a single face. In 1974, I completed my PhD at the University of Chicago and went out to Ethiopia for my first major full-scale expedition, and had some National Science Foundation money that got us out there. And that fall, in November, at this locality, where you see the people standing, I made a discovery of a partial skeleton, which has now become more or less iconic, a skeleton that was nicknamed Lucy, after Lucy in the Sky with Diamonds, a Beatles song that was playing in camp the night of her discovery. And one of our expedition members, Pamela, said, well, if you think it's a female, why don't you call her Lucy? And she picked up that moniker and has been known as Lucy ever since. Well, what did I find? The first piece I found was not a molar. It was this little fragmentary piece of bone, which is the elbow on the right side. It is the ulna, the bone that allows you to flex and extend. As you can see, it's like a little wrench. It's not the one that turns your forearm, but the one that flexes and extends. And I kneeled down and looked at it and knew virtually immediately from its anatomy, there are features in this, in almost every bone we pick up, that easily differentiate between human and non-human. The only thing it could have been was a baboon. It was the right size for a fossil baboon, but it didn't have the right kind of anatomy on the back side of it. It had our kind of anatomy. And then on the left, you see a much younger and thinner me. with my graduate student who's doing all the work, but that's what they do. Wrapping up each and every fragment here in toilet paper, which is, we have these huge boxes of toilet paper that follow us to the field, and marking each spot where the large bones were discovered before we started systematically scraping and cleaning and screening and so on. So it was that single bone that led to a excavation where we had a small team out there, a team of geologists, anatomists, paleontologists, and so on, screening every part of this hill. And this is a photograph for the first time ever that these bones were more or less re-articulated after 3.2 million years. We knew at the time that it was older than 3 million years. We didn't know how old exactly. This is the French colleague, Maurice Taïeb, who was so generous in inviting an international team to come and work. And we basically had a French and American team working there. And this is the image which has become so iconic, a partial skeleton. Unfortunately, the skull eroded out first and rolled down the hill and broke up. So all we have are fragments of the brain case, but importantly, enough of the back and the sides to give us this cranial capacity estimate. A number of things were important about her. We had her pelvis, which is a very fragmentary and fragile part of the body, which tells us a lot about locomotion. And we had the knee and we had the ankle. And it was clear from the detailed anatomy working with an orthopedic surgeon that in every one of these anatomical regions, so important for reconstructing locomotion, this was a creature that was fully upright and bipedal on the ground as we are. Clearly, her legs were very short. If you compare the length of the upper arm bone, the humerus, with the thigh bone on the lower right there, the femur, they're almost of equal length. As you see, if you just look at your own body, your thigh bone or femur is much longer than this because, as I said, our lower limb is our lever arm for getting around. She was clearly very different in terms of details of teeth and jaws and skull and so on, and a distinctive new species of Australopithecus. And I named her after the Afar people in the Afar region. She is known in Ethiopia by her own name. She's known as Dinkin Ash, which in Amharic means you are wonderful. But regularly driving around Ethiopia in the countryside, you'll come across something like this. Lucy College, there are Lucy cafes, there are Lucy magazines, the national soccer team of Ethiopia, women's soccer team is named Lucy. There's a Lucy Cup in soccer. So she's known more often as Lucy than as Dinkin Ash, which is commemorated in this stamp that was minted in 1985. So this is more or less what a complete reconstructed body would look like. And as you heard, we now have many, many different specimens. We have, at Hadar itself, 90% of the sample that represents afarensis, and that's about 400 specimens. And I know there are undescribed in Ethiopia, in the museum where Lucy is stored. All these fossils are back in the capital, in the National Museum, that there are another 300 or so specimens. It is a species that lived between about 3 million years and 3.4 million years. So it's one of the longest lived species we know of in the human fossil record. We've been around for, as we are now, maybe 100,000 years. So her species was an enduring species. It's found throughout eastern Africa, what is today Kenya, Tanzania, Ethiopia, out in Chad, for example, in north central Africa. And in 1976, Dr. Mary Leakey, who was in charge of work with her husband Louis Leakey at Olduvai Gorge, which some of you may have visited or certainly know about it, came to visit me in the field with her son Richard Leakey and be dazzled by the fossils that we were finding. We hadn't found Lucy yet, but she was encouraged to go back to a site in Tanzania where she and her husband had worked in the late 30s and didn't find any hominids, didn't find any human ancestors. But it was about the same age as the Lucy site. And they found a trail of human footprints impressed in a volcanic ash that's 3.6 million years old. And there was a volcano that was erupting in that area. It was a special kind of volcanic ash. It was a carbonatite. It had a lot of carbonates in it. So it was at the beginning of a rainy season, and when it covered the surface, there was a light rain, because you can see raindrops in there, and a couple of human ancestors that were the same species, because we now have the teeth and jaws of this species at this site called Laetoli, walked across that surface and left imprints of their feet. And it's like all of us in this room going to the beach and walking in moist sand, let's say at sunset, and looking back. That's what our footprint looks like. But this footprint is 3.6 million years old. It's got a strong heel strike, it's got a strong toe off, it's got a transverse and longitudinal arch to the foot. And this was all predicted on the fossils that we had found, and it really documents in a way we never thought was possible.
And what about Lucy herself? What did she look like? We know from the teeth, the jaw, and now the skull fragments we found that Lucy had an ape-like face with a brain just a little larger than a chimp's.
The piece I did for a three-part series for Nova, it's an animatronic.
She may have had dark skin and patchy hair to protect her from the sun.
You know, chimpanzees do this, and I thought if chimps could do it, why couldn't Lucy do it? Termites are great. They're roasted. I don't like them raw. If you ever go, and roasted, they're wonderful. And,
Walking upright freed her hands to develop a more precise grip than other apes, more like our own.
And the hand bones we have bespeak a hand that was certainly capable of finding.
And even with her small brain, perhaps she was beginning to have a more human-like awareness of herself and her surroundings. Lucy and her kind must have been extraordinary creatures. We know that they persisted as a species virtually unchanged for over 1 million years.
So this was a long-lived species, which is very important, and geographically widespread, meaning it lived in a series of different habitats. And more recently, we have begun to find more complete skulls. For instance, this is a beautifully complete 3.1 million year old, 3.2 million year old skull, meaning the face, the brain case, and the lower jaw, of what a female of Lucy's species would look like. And it's allowed paleo artists to reconstruct, I think, more accurately the shape of the face, much more ape-like, as you would imagine. And we've also begun to find complete skulls of males, which are considerably larger than females. So there was a lot of sexual dimorphism between males and females. Lucy is, as people say, probably the best known fossil of the 20th century, and as certainly become the benchmark by which other discoveries are judged. If something new is found, like recently you saw in the National Geographic magazine, they immediately say older than Lucy, or younger than Lucy, or more complete than Lucy, or maybe an ancestor to Lucy, or maybe one of Lucy's descendants. And she has become part of our vernacular. If you watch Jeopardy, occasionally she appears on there. She appears in crossword puzzles when the little clue is human ancestor begins with L, 4 letters. My favorite one appeared in, I think it was Science magazine, where Lucy goes to a cocktail party. Says, "Oh, not the Lucy." So she's become very widely known as kind of the ambassador. And also, most recently, I don't know how many of you saw, believe it or not, Scarlett Johansson, spells her name with 2 S's, as my parents did this movie called Lucy. Anybody see this movie?
You know what? The other day I was in this museum, and you know what I found out?
What?
The first ever woman was named Lucy.
It's a very funky plot.
Is that supposed to make me feel better?
Yeah. No.
So this movie had been out for quite some time, and I was at a dinner party in Santa Monica, and someone said, "Have you seen the movie Lucy?" And I said, "No." And they said, "You know, it's about your Lucy." And I couldn't believe it, but there it was. So as you heard, Lucy is not alone. It was funny, a number of years ago, I was on an airplane and talking to one of those people you can't stop talking to. You know, he's going to talk to you whether you like it or not. And he said, well, did you ever find anything else? So it was a good question. So we now have an extraordinary insight into the anatomy of virtually every anatomical region, and trying now to look at microevolutionary changes over time. It seems to have been a very stable species that underwent very little change, perhaps a slight increase in body size over time, but a very stable species, and is the reference collection, the go-to collection for all paleoanthropologists who make discoveries now. The first place they go is to the drawers where Lucy and the other fossils from Hadar and the afarensis fossils are stored in Addis Ababa. We know an enormous amount about this genus. We belong in the genus Homo, which is Latin for man, as you know. And yet we know much, much more about the ape men, or Australopithecus, and the diversity of species, the specializations in anatomy and behavior and diet, than we know about the origins of our own genus. And most recently, we have begun to concentrate in areas where we're finding sediments that are between 2 million and 3 million. Lucy's species, as I said, afarensis, disappeared at 3 million years, which was a very eventful moment in human evolution, and an eventful moment in terms of climatic change. Because at the 3 million year time level, there was a major shift from a wetter, more forested environment to a drier, more open environment. And we saw lots of diversifications in animals that we think of traditionally as savanna animals, like baboons, speciated into a number of species, like the great diversity of antelopes and gazelles that make a living out in these open areas. And it generally thought that these earlier Australopithecus, like Lucy, lived in more bushy or more woodland, not deeply thick forested rainforests, but certainly an environment was different. And at that time, one of the great generators of change, biological change, with natural selection working, is climatic change. So what happened was there was a major change. That's when Lucy's species disappears. We see a whole proliferation of different kinds of vertebrates living in open areas, and we see a major bifurcation in the human family tree between our own genus, Homo, which has emphasized brain expansion, and an increased diversity of Australopithecus species that are now beginning to occupy a whole new set of ecological niches, as I will show you. So the switch has turned more to the origin of man, the origin of Homo, which a New Yorker cartoon so neatly pointed out. Oh yeah, well, what if I were the first man on Earth? And there have been some recent discoveries. I'm happy to say that part of those were made by my team. This is a upper jaw. This is the roof of your mouth, right here, your palate. And you can see from the top that a chimp and Australopithecus have very long, from front to back, narrow, parallel-sided tooth rows. That's a feature we inherited from our ape ancestry. But our own species, everybody sitting in this room, Homo sapiens, we have a much more parabolic arch to our arch. It is very deep. If you put your tongue in the top of your mouth, it's very domed. Australopithecus and chimps have a very shallow palate from the bottom of the teeth to the roof of the mouth. And you can see how ours is wider from side to side, shorter from front to back. And this is a 2.4 million year old upper jaw that was found at the site of Hadar in much earlier deposits, more recent deposits, and was for a long time the oldest anatomical evidence that we have of our own genus. Not very much. Yet it was associated, interestingly, with stone tools. Tools, this doesn't probably look like very much to you. Some of us have stones in our driveways that look like that. But there are features of that, such as this flat platform up here where it was originally struck, this sort of bulb of percussion here as the shock waves go through the rock. And they're found in an area where it's very fine grained, so someone had to have purposely brought in that raw material and made the tools there. And that's the oldest association between our own species and our unique mode of adaptation, which is culture. Now, most recently, a group from the Institute of Human Origins went off to a site up here in the corner called Lady Gararu, which is not far from the Hadar star there where Lucy was found, and began looking in deposits that I explored in 1972 that were not very fossil rich. But I collected enough pigs and elephant fossils from there to know that this was around somewhere between 2.5 to 3 million years. Pig fossils and elephant fossils are very time diagnostic. For instance, if we all go out this weekend and collect a dinosaur tooth, you know that rock is older than 65 million years, right? Well, elephants and pigs evolve very quickly over time, and you can use them as time diagnostic. So a colleague of mine, Kay Reed at the Institute, went out, got a permit to work there, and her team announced, you may remember this spring, the discovery of what is the oldest evidence for our own genus. Again, it's fragmentary, unfortunately. We have a fragment of mandible on the right there from the top of that hill. It was discovered by one of our Ethiopian students. Very interesting developments in Ethiopia. When we first went there was no lab, there were no people interested in the subject. Today, there's a major commitment by the Ethiopian Ministry of Culture that has built a fabulous lab. There are now about 10 well-trained students by our team and a couple of other teams who are Ethiopian nationals who are beginning to undertake their own explorations, put their own teams together, and make their own discoveries. And appropriately, this lower jaw was discovered by one of our Ethiopian students. And there are features of this, such as the long, narrow molars, for example, and many other features in that jaw that suggest that this is the earliest Homo at 2.8 million years. Now, that is most interesting for me because when I announced Lucy in 1978, right on the heels of that, I published a major overview in Science and suggested the possibility that Lucy's species, afarensis, as a generalized species, meaning it was not very specialized in any direction, could be the common ancestor for our own lineage as well as other lineages of Australopithecus. And this helps bolster that view. Ethiopia has played an incredibly important role, mainly because of geology, but now because there are so many teams going there. When I found Lucy in 1974, actually the year before I found a fossil knee, no one had found a human fossil in that region of the Afar Triangle that's 600 miles on a side. And that led to sort of a hominid rush, like the discovery of gold in California. And other teams, who became competing teams, went out there and started searching. And the record in Ethiopia ranges from about 5.8 million years ago right on up to the emergence of Homo sapiens at 200,000 years. So it is an extraordinarily important and complete role. Well, you may all heard that the new governor of Kentucky, who's been elected as a creationist, so he's obviously, these guys are going to the Creation Museum in Kentucky. But this is the photograph or the depiction we all see so often every month or so. New Yorker has some form of this. That it's an inexorable march from, as I say, ape to angel, because we all think of ourselves as being such angels. But even Darwin knew that there is no direct line from ape to human, that all the evolution of all creatures, whether they be plants, insects, vertebrates, humans, or whatever, is basically a tree. And he drew a tree in his origin in 1859. And that is indeed the case. This is kind of my version of the family tree. Everybody in my field has their own version, so there's a veritable forest out there. But what I want to point out here is that here is Lucy's species dying out at about 3 million years and living for about 1 million years of time. We know her ancestor at about 4.2 million. There's no question about that. And we know something about her descendants based on anatomy. This lineage and these two lineages. And this is the first time we've been able to actually to trace lineages in the fossil record. This was a group of Australopithecus that were devout vegetarians. They had massive faces, huge molars, big crests, massive chewing muscles like the temporalis and masseter muscles, and they specialized. And as the climate got drier and drier in East Africa, and as the antelopes and gazelles and savanna baboons and other forms of animals came into competition, they ultimately went extinct. They did not leave descendants. So that part of the hypothesis that I published in '81 has been fairly well established, with intermediate forms between afarensis and their very derived forms. And it's only just recently now that we've been able to begin to fill in this branch leading to Homo. So it's a hypothesis. It continues to be strengthened by discoveries. And what it does is it really puts Lucy's species, afarensis, at a pivotal point on the human family tree, where we had a fairly impoverished family tree here to a very species-rich tree. Many of those species went extinct, Neanderthals disappearing about 40,000 years ago, about 5,000 years after we entered Europe, and some other species that went extinct. So Lucy's particular place on the family tree is very important in terms of understanding the dynamics of evolutionary change, and ultimately the emergence of all of us in this room, Homo sapiens, about 200,000 years ago or so. So this was one of those moments. Oops, sorry. I had a little nervous finger there in that movie, Lucy. She actually goes back and meets. Very funky. But we all know where this came from. This image right here. So that is more or less the story of Lucy and her discovery, her importance. Important role she's played in my life, of course, as an anthropologist. And this is my email if anybody wants to be in touch with me. I have a website called becominghuman.org because I think in many ways we're not there yet. We're just becoming human. And I just released 14th of October a MOOC on edX.org that is entitled Human Origins. It's 8 weeks of lectures about, I guess there are about 6 or 7 lectures a week. They're about 15 minutes long, illustrated. I had been asked by Coursera to do a course online, and I really wanted to do a course that was free. I wanted people to have total access to this, particularly because of the third world countries in which I work, where they will never have an opportunity, many of these people, to take a course in human evolution or human origins. And my Ethiopian colleagues have already written me, some of the people working in the National Museum, who have really no formal education in human evolution. They are all glued to their screen because in this course they learn what otherwise they would not have available, because the course is absolutely free. You have to enroll at a certain time. And if you want credit, it's like $400. There are about 10,000 students now taking this course. It's the first time it was offered. It'll be offered again next March. But these are additional resources if you would like to follow up with anything. And of course, I'm available on email. Thanks very much indeed.
Any questions for our talk? Yes.
So, you described Lucy between around 4 to 3 million years ago. Were there any other human species or humanoid species at that time? In your diagram, there weren't any.
Yeah, the question is, were there other species of humans living at the same time as Australopithecus afarensis or Lucy's species? This is a question that we are debating at the moment. An Ethiopian colleague of mine found at about 3.4 million years which means a couple 100,000 years older than Lucy, north of where I work, a very interesting foot skeleton and partial limb skeleton that has a divergent toe. And that is Lucy's toe, or afarensis. We have a complete articulated foot that we found one year. And those feet are like our feet. You saw the footprints and so on. So that is, he thinks that's a new species. He hasn't named it a new species right now. But I know in private conversation with him that he is on the verge of putting together an argument that it is another species. That would probably be a species that's a descendant of Australopithecus, which I haven't talked about, which is at 4.4 million. And while, and it has a very large divergent toe. So there may be two lineages there. There is a discovery by the Leakey family on the west side of Lake Turkana, which they have given a new species name to, and most people don't think it's probably a new species, but that may be another lineage. I think it would be very unusual if afarensis were the only species. Even up as recently as 50,000 years ago on planet Earth, we had Homo neanderthalensis, we had Homo sapiens, we had Homo erectus, very late Homo erectus in Java. We had Homo floresiensis, these peculiar little hobbit-like creatures that are found out in the end of the Malay archipelago, and perhaps these Denisovans that have been recognized in genetic analyses. So at just about every point, you had 3 or 4 or 5 species. But then there was a major winnowing of those species, and that is directly correlated, really, with our emergence. Wherever Homo sapiens went, whatever species was there as a human species very rapidly disappeared. And there is an interesting article by one of my colleagues at the Institute of Human Origins, Curtis Marion, in the September issue, the cover issue of Scientific American in September, called How Humans Conquered the Planet. And in there he makes a case that the refinement of the features that we really consider as modern humans, symbolic language, cumulative culture, and significant cooperation, division of labor, and so on, really emerged in Africa in that very diverse mosaic set of environments. Neanderthals had evolved into a separate species in Europe directly in response to 2 things. One was genetic isolation, so there was recombination and mutation and natural selection, but also an physical, physiological, and anatomical adaptations to a periglacial environment. They were living with glaciers in the distance, 3-4 miles thick, and their anatomy shows that. But he thinks that the things that really make us who we are today came out of Africa, which alters dramatically, and I've said this for years, the early view we see in Time Life books on early man of this, upright, white-skinned, French-looking guy, in Europe as the first humans. Whereas I think it was probably much darker-skinned people who came out of Europe and displaced Neanderthals, brought about the extinction of floresiensis and erectus and so on. So I'd be very surprised if there were not other lineages or other species at the same time.
If I am remembering correctly, you said that afarensis lived till about 3 million years ago, and the earliest Homo species was 2.8 million?
Yes.
What is it that distinguishes Homo from Australopithecus that you can say, now we've got a new genus?
Well, I showed you the mandible, and there are a number of features in there: the shape, the elongation of the teeth, the reduction of buttressing of the anterior portion of the mandible, the particular place where the what's called the ascending ramus arises, and the shape of the arch in a parabolic fashion. We don't know exactly why those came about. We think it has something to do with more flexion of the craniobasal areas of the skull that brought this face in and shortened the arch And in relation to that, it began to broaden. But there are lots of people working on that, trying to figure that out. It isn't just the stone tools that are found with them, because that, doesn't define a species. And the upper jaw I showed you, I think, was very convincingly different from an Australopithecus. So what we would like to see, of course, are cranial remains to see if there's much difference in not only cranial capacity but cranial shape between Australopithecus. Now, the palate, if we look at it in lateral view, it is not prognathic or projecting. It's very flat like ours. Our faces are very flat. So there are those subtle features that all line up and accumulate to convince us that Homo is very different from Australopithecus. Does that answer your question? Yeah.
All right. One more.
So you mentioned that most of the fossils of Lucy's species are kept in the National Museum in Ethiopia.
All of the specimens.
All of them?
All the specimens that have been found in Ethiopia of human ancestors now reside in the National Museum in Addis Ababa, yes.
So given what's happening in Iraq and Syria and so on, are you worried that someday somebody may steal them, or what are we doing to protect them?
Well, I'm more worried that there's going to be a massive earthquake. As you get earthquakes, the Rift Valley is very unstable, like California and the western coast and the Ring of Fire. They are stored in very substantial safes. There are guards at the museum all the time. There is a trained group of Ethiopian scholars now who are totally dedicated to this. Some of them are still in Ethiopia teaching or working full-time at the ministry. But, of course, we never know. I think there is no anti-evolution movement in Ethiopia like there has been in Kenya because of these radical Baptists who have been going over there and converting everybody to Christianity and saying that this evidence needs to be destroyed, sort of like the ISIS point of view. It would be very difficult for anyone to steal these. It would be very difficult for anybody to come in and destroy them. But we never know what happens. In 1940, when was Pearl Harbor? Was that 41?
41.
All the Homo erectus, all the Peking man fossils were shipped from Peking to the China Sea, South China Sea, to save them from the invasion, and they vanished. They've never been found. They never made it aboard the USS Harrison. So things like that happen. Yet on the other hand, you have the first Neanderthal found in 1856 in the Neander Valley, Neanderthal, near Dusseldorf, and that survived and still is in Dusseldorf because it was kept in a safe, and was the first fossil Neanderthal, the first fossil human ever found in Europe. But in addition to that, it was the first fossil specimen that gave us DNA. They drilled into the arm bone of this 1856 Neanderthal that nobody knew about genes back then, right? Fortunately preserved, fortunately organic material in it, and fortunately getting a DNA sequence out of it. So it works both ways. But I firmly believe that these fossils belong in the discovery, in the country of discovery, and that it's incumbent on us as scholars coming in at their invitation, having this privileged opportunity to come in, to help them establish these organizations like a major laboratory, like the National Museum, to house these specimens. And let's hope they do continue to survive. Maybe someday someone will develop a method to actually date the fossil and not the volcanic ash, for example. That would be a significant contribution.
Well, thank you very much for speaking with us today. We'll have time for a book signing afterwards. So thank you
Thank
for
you.
stopping by.